In this video, we are now going to quickly once do a sort of recap of the process that was followed to create a final polished version of the notebook and also see some of the great work that other people have done on this same dataset. So this is the main objective as I've mentioned multiple times, whereas even though we are doing on the specific dataset, we want to understand the process in general. So for that, what we want to follow as instructions is anything that we use in this particular notebook. It could be either to see parts of the data, to visualize, to do some pre-processing, feature engineering, hyperparameter tuning, model building, evaluation, whatever it could be. We want to be very clear of how these things work. So if someone were to take any portion from the notebook that you have created and ask a question on why have you used this, how does this work, how did it help you, we should be able to answer that. So for that, it is always good to once you do the work to also document it right away. This will ensure that when you come back to it after maybe weeks or months, your project still remains fresh and you'll be able to get back to it a lot more quickly. So for presentation aspects, once I finished a few versions, I have moved all the imports to one section. And then, as I mentioned, we have the case of reading the data sets, and we have to be very clear that even if you do not know it on the top of your head, you should be able to search for different methods to read different kinds of data sets and be able to get it into a tabular form. One other thing to note here is that even though we first start off with the pandas data frame, once we use certain methods, it could be the pre-processing methods, it is possible that those methods will change the type of data from a data frame to a NumPy array. This also means that a lot of the methods that we used to use previously on the data frame will not work on these NumPy arrays. So it is very clear you can use type. So you can simply do type of whatever you've had here, maybe a string, run the cell, and then it is going to tell you what type you have currently, and that dictates what methods are allowed. So this becomes handy when you have to code live and you have to deal with errors. So with that, the next thing, as I mentioned, is knowing the dataset itself. These give an idea of the values taken, which ones are numerical, categorical, and so on. So that is why I understand these features. And if you've done these things previously, have them as sort of ideas, but don't let that direct the analysis that you are doing. So once whatever the data communicates, whether we agree with it or not, the process is has to be unbiased. Then we saw this function, even a tiny function such as this tells us about null values, data types, and so on. And then these are the observations that I've done. So as I mentioned, you can mention the categorical columns and numerical columns here. So later on, when you come and when you're asked what are your categorical columns, you already have it present somewhere. Now, this is one other point wherein even though you have numerical columns, for example, let us take uh, the class or a standard student is in a school. So instead of naming it as 1, 2, 3, it might be used as 1, 2, 3 as seen here, or we could see the Roman numerals where we have the representation with I and two I's and so on, which stands for 1, 2, 3, of course. But those representations would then make it look as though these columns are categorical while they have an ordinal and a numerical sort of flavor to those particular columns. And even a method such as describe, it's not that we are simply going to have in our notebook. We are going to use this to understand scale, understand about outliers, get a rough idea about the distribution of different columns, see if there are columns with very low variance. So we might want to drop out the columns which just take a constant value. So once again, these are written here. Same is the case with null values. As I mentioned, there are many methods to handle null values. If necessary, you can go back to your MLP course to look at the video on handling null values. And same is the case with outliers later on. But these are all choices you have to make consciously. So we cannot simply use a simple imputer or drop all the rows and just proceed with it as though it is not connected to the project. So if you're going to use a simple imputer or if you're going to use KNN imputer, you would want to mention your decision choices here. We have used simple imputer, we have used these methods for these columns, and we wanted to use KNN imputer because we want to impute based on similar other rows. Duplicates are quite unnecessary in a dataset, so we can directly drop them. And we can see how many unique values different columns take. And as I mentioned previously, this cardinality can decide the kind of encoding that we want to do. Now, individually seeing the features can help understand the kind of categories that it takes here. So, as you can see, it can have these different variants that the same data set has for the column, or it could be typos. And then it comes to EDA, we first saw the target variable, we understood about its imbalance. That tells us that if we are not aware of imbalance handling techniques, this is a good point to look that up and come back. So the data set is imbalanced, imbalanced handling techniques, the evaluation metric that we use, then the univariate feature analysis to understand about dominant categories, whether we can convert the loan grade because ordinal because it seems to have an altering. So for this, you might want to go back to the domain knowledge. You have to go to how these different financial institutions actually grade the different loans. Does a loan grade A mean that it is higher than say loan grade E? So these are things you would want to look up. You would want to search for this information and then base your pre-processing technique on that information. Then we did some box plot. Here, as I mentioned, we need to be clear why, how does this box plot work? Why are these points outliers? And if I remove these particular points, is that a valid approach? Once you remove this and plot, you're going to see a different distribution. Now, does this suffice for my model building? Is what I've done, is it a right approach? So these are all questions you have to ask at every single point. Okay, we've had the same thing. So this is one other point. So in some cases, what we think are outliers. Now here we are taking the case of say a lot of money transactions. There might be very large values, and clearly those points are going to stand out from the large amounts of money. They might stand out from the other values. So in those cases, they might actually be indicative of fraud. If we are doing fraud detection, that might be the one that helps us identify that it is a fraud. So we have to be extremely careful when we are going to drop outlines. So the moment we drop these things, we have lost some portion of the information, but we have to be clear that it was a valid approach to actually drop. Now, this is to show that if you see the train and test, they follow a similar distribution and it might not be a good idea to drop what we think are outliers. Then we did some bivariate feature analysis. Here we have to note that there are features that are highly correlated. Then there were some features that were correlated with the target. Are these columns actually contributing later on even in the model building? And then here, as I mentioned, questions. What is correlation? What are the values it takes? What does a value of 1 mean, minus 1 mean? If they are highly correlated, how do they impact models? For example, models like linear regression are impacted by multicollinearity. So what is multicollinearity? How do I deal with it? Do I drop columns? Do we use different regularization methods? So this is how all the methods that you've learned in your courses tie together. Then when we saw that there were some categories that were not very dominant, but if you actually look at them individually, you see that these categories themselves also could be important. Same is the case with outliers. So we have a clear pattern here, whereas wherein for the loans that were approved, the income of the person tended to be on the lower side. So this could again have something to do with domain knowledge that you can gain. Later on, we did a plot. We saw that higher interest rates tended to be approved more. And then about the validation set. So this is so that the model does well on unseen data. You can use it for hyperparametric tuning. We also brought up the case of stratification. Do we want to stratify the data set? So if you don't know, you also need to look up what is stratification, and that actually helps with imbalanced data sets. And then comes the feature engineering part. Once again, I'm going to show some of the other notebooks for this part. And then the pre-processing. Even though this is a very small and simple code snippet, you only need to replace these with the different encoding methods, scaling methods you want to use. For example, if you're going to do, say, feature selection here, you're just going to add the part about feature selection. Maybe you want to use, say, recursive feature elimination, or you want to use using the variance threshold. So all these different methods, you are just going to have to edit the pipeline. So once you have this base version, it is much easier to try out different versions of your experiment and make more submissions. Yeah. So at this point, question, what are these different encoding methods? You've learned a good number of encoding methods in your courses. Go back and read about what these methods are, how do they work. Now, one hot encoding gives many columns, so it increases the cardinality, it increases the number of features that I have. Ordinal encoding brings about an artificial ordering to my features. So we might not be happy with those. So instead, can we go with target encoding and for frequency encoding? So what is target encoding? It is something where the values for a category is replaced by the mean of the target variable. So this way you want to look up what these methods are and what are the advantages that I get or disadvantages that will happen when I use it. For scaling methods as well, if I use standard scaler, what happens? Now, if I have outliers, maybe using robust scaling is better. So these are all questions you have to ask at every point, and this will also help you become much more comfortable with the theoretical aspects of how these methods work. And then how many features do I have after pre-processing? Maybe you used one hot encoding and then you used feature selection or maybe PCA. How many features am I left with? So it is very important that you know very every part of your data set quite thoroughly. Then we spoke about a baseline model. This is to ensure that our pre-processing has been done properly and the data is ready for model building, and also to give an idea of what might be a good score. Then we wrote a function to check the scores of different families of models. This is a rough idea where we've not tuned most models. We've simply run an experiment to see what could be good candidates. Because if you notice, there are certain cases where models like naive Bayes, this is in the case of text data, model like naive Bayes might perform better even compared to ensemble methods such as random forest or say boosting. So this is to give an idea of how these things work. And as I mentioned, you can run this function and maybe try out some other EDA in the meantime or pre-processing techniques and then come back, and based on these results you again make changes. So we mentioned some similar pointers here about the lower F1 score and about the models that have done well, about overfitting in decision tree. These are all important observations that you need to add in your notebook. A good presentation is important. Here as well, you can see it might have been better to actually annotate and write the values on top of the bar. So that way you can just read the scores of this chart directly, the actual value. So we've done it for different evaluation metrics. And then, of course, the hyperparameter tuning part. So here, there are again different ways to do your hyperparameter tuning. So we've done grid search CV, but the problem with grid search CV is it is going to take all different combinations and it will be a very time consuming process. So if you take models such as say support vector machines, you might look at maybe 3 to 4 hours of just hyperparameter tuning for that one model, and you might not even end up with a very good model. So in those cases, once again, you are going to have to make a choice. Do I instead go with randomized search CV? Do I reduce the number of folds? And also the evaluation metric. So these are just a couple of methods, but in modern times, there are even methods such as Optuna, which tend to do a better job. And I would also recommend looking this up and experimenting with Optuna to do the hyperparameter tuning. Then, of course, we showed XGB classifier. This is to say that boosting models do extremely well in these things. So, boosting models and ensemble methods such as stacking, and now there's also blending. These you will see are models that tend to perform very well on tabular data sets in Kaggle competitions. They used to dominate for a large period all these competitions, but now there's of course deep learning based methods. Regardless, these are things that need to be in your repertoire of methods that you are going to try, but the difficulty is in knowing what all these parameters are, how do I tune them, what is a good approach. So there are plenty of resources online. Do check that up because these models can help you get a very good score. Now, one of the things I've done is once you do hyperparameter tuning and get these what you think are your best models, later on when you're submitting, you don't want to go through the hype when you're submitting your model to the competition, that is. So when you have the submit button here, you don't want your model to do the hyperparameter tuning again. So you can simply comment out that part and write the code snippet for the best model and use that for your submission. Then, of course, comes model evaluation, which we told is the most important part because at the end of the day, any method you do should contribute towards a better score. So, for that, understand the evaluation metric, interpret these things to know where your model went wrong, have a quick snapshot of multiple different evaluation metrics in one go, and then, of course, interpretability of your model through something like feature importance. Then we've done the submission. So, this was broadly the process that we followed in this notebook. I'm going to briefly show some other notebooks as well. So this is, of course, since it is in Kaggle, you have to understand that this process is a bit like creating something new. You're going to take different ingredients, combine them in different quantities, and experiment with it to bring out your own flavor. But at the same time, you can also look at these sort of standard recipes that these other experienced folk have done and try and emulate that as well, because that will also contribute towards making your final product better. Now, this is a beautiful presentation. So, this particular individual has done their EDA, and then very nicely for each column, they have written their analysis. So, this also follows with, so this is the feature engineering part. So I've not shown it specifically, but different new features have been created. So loan to income ratio. Then what is the financial burden? So that is given the loan amount and the interest rate, how much is it that a person has to pay back? So this could be from the idea that if a person has a lot of financial burden, they might not be able to pay back all the loans. So if that is the case, you do not want to approve a loan for such a person. So that could be the thought process. And later on, even the part about scaling, which of my models are impacted by scaling. So when you use this method, and maybe later on you used, say, a logistic regression method or uh, k-neighbors classifier in this case, of course, and you have to ask the question. So if I did not scale my data set, is it going to be a problem? So we know that for logistic regression or for k-neighbors regressor SVM, it is a problem if you do not scale the data set. So if you don't know, you have to ask the question why. Why is it a problem if I do not scale? Likewise, if you take random forest or decision tree models, you don't need to scale. Why is it that I don't need to scale? Simply put, of course, to recollect, for k-neighbors regressor, because you use distance as a metric, features being in different scales can impact what you get as your nearest neighbors. Whereas in the case of decision tree or decision tree based models, each feature is looked at individually. There is no comparison of features that happens when you train your model, which is why it is okay to not scale the dataset. However, you need to have a very thorough understanding of these things. One other point is scaling your data can even speed up the convergence of different models. So when you are using, say, gradient descent based algorithms and you want to get to the ideal weights, if you scale your data, it can actually help your model reach convergence faster. So that way, these different notebooks, let's look at one more. Here, a person again has created a lot of their own features. You can see something called as a risk flag. So this combines whether the person has defaulted and the kind of loan grade that they have. So this can indicate that loan grade might have something to do with a risk of the person not paying back the loan, and also if they have a previous history, maybe you do not want to give that person a loan. So this way you can create multiple new feature engineering or do some feature engineering. Now feature engineering doesn't just have to be about creating new features, it could also be about transformation. So here you see this is of income distribution, and mostly you see that it has a very long tail. So instead of that, you can transform this particular feature by using log transform to now sort of bring it to a different distribution. So this is also a valid feature engineering approach. Now, once you do this, you again, of course, check with your evaluation metric, see if the performance is better, and based on that, you can retain it. Now, this is a notebook wherein the person has clearly explained the evaluation metric as well. So this shows that understanding of this evaluation metric is very important to building good models. Now, so this is mostly what I wanted to cover with this video. So you can go to this competition, and once you build a template such as this, you can reuse the code across different competitions and data sets. You would only have to change the feature names, and it is important to try out multiple such data sets and competitions, because every time you're going to come up with new errors, you're going to come up with new issues, and you have to be creative and come up with newer solutions to improve your score. Because if you've done this a lot, you will realize that even increasing by decimal points, increasing your score by decimal points is a challenging task. And that is going to require you to experiment a lot and try out various things.